Thanks a lot for still being here. Last presentation of the last session of this conference. This is joint work with Emmanuel, who you heard already, and Jean-Marie. And it's back to empirics, so we're back to data. Here's the question. What is the effect of metals on wine prices? So that's a very easy question. So I think that 10 minutes will be enough to give an answer. We have data on metals from about 10 competitions for Bordeaux wines, and transaction data from a broker here in Bordeaux. And the focus is on the causal effect of metals on wine prices. Not that mere correlations are not interesting, but for the most interesting questions about the relationship between metals and wine prices, you need to identify the causal effect. So here are two questions. For instance, where you need the causal effect of metals for producers. Should a producer participate in some competition, given that he has to pay the participation fee? For the consumer, the question could be, what is, given the quality of the wine, what is the extra premium, the extra cost that I have to pay for the metal? So these are two types of questions where causality is important to know. Obtaining causal identification is a challenging issue. Why? Because if you regress simply the price on an indicator of obtaining a metal somewhere in the past, then the standard OLS estimate will probably be upwards biased because of omitted quality bias. Now, to avoid this bias, we have a very simple idea. And here's the idea. We regress the price, not only on an indicator for past medal awards, but also indicator on an indicator of future medal awards. Okay, so we have in the data very precisely the dates of medal awards. And it turns out that under certain conditions, the difference in the two estimates, so the estimates on of the coefficient on the past medal award and the one on the future medal award, the difference of these two OLS estimators is an unbiased estimator of the causal effect. The data. We have two data sets. So one is a transaction data set from a major broker in Bordeaux. So brokers act as intermediaries between producers and wholesalers. We have about 15,000 transactions. And the second data set is these data on metals. Okay, we have colors and all kinds of information on these competitions. Okay, 10 competitions. And we merged the two data sets because we have the names of these wines in both data sets. So the 10 competitions differ in nature. That is something we won't exploit too much today, but there are old ones, the ones from Bordeaux and Paris, the best one known date from respectively the 19th century and the 1950s. The most recent one is from Lyon, it dates from 2010. Different types of juries. You have, for instance, the Feminalise competition, which is the jury is only made up of female tasters, different fees, etc. So crucial for the analysis is that the transaction dates and the competition dates, so when the medals were awarded, are exactly known on the dates of the day we have. So medals can be awarded before and after the transactions. So in blue are the frequencies of the transactions where a medal was awarded before the transaction, and in red the wines the frequencies of the wines where the medal was awarded somewhere in the future, so somewhere after transaction date. Here are some statistics on prices. So if you manage to read this, let us focus on wines from the Médoc and the Haute-Médoc. So you see that for M is 0 and F is 0, so I anticipate a bit on the notation that I will introduce in a minute. M is 0 if a wine has not obtained a medal in the past at the transaction date, and F is 0 if there won't be any medal in the future. M is 1, F is 1 if there's a medal in the past or a medal somewhere in the future. So M is 0 and so M is 0, F is 0. The average is so small that I can even not read it myself. This must be somewhere around 2 years. Okay, and when M is equal to 1 and F is equal to 0, it's about 3 years. So 2 remarks here. Prices are wholesale prices. So these are not the prices that consumers will finally pay. So the prices will be a bit higher for the consumers. But this being said, the prices are still very, very low, right? And the reason is that these are not the wines that Philippe has talked about. These are the table wines, the 95% of the wines in Bordeaux, but much less well-known wines that you guys, most of you guys work on. Okay, simple methods to avoid the unobserved quality bias. You see this first equation? That is an assumption, and this is an assumption on the data generating process. So we assume that the data that we have on prices and medals are generated by this equation. So left-hand side is the logarithm of the price is equal to a constant plus beta 1 times mi plus qi plus epsilon I. Mi is equal to 1 if wine I has obtained a medal before the transaction date. Qi is the quality that we assume constant in this simple setting. Most wines are sold within 3 years after the harvest. Okay, so that won't shock you too much. And epsilon I captures all the unadmitted price determinants. Fi is the indicator that tells you whether a wine will obtain a medal somewhere in the future. Okay, at the transaction date, you know that somewhere in the future I will get a medal. So we make several assumptions. We go from the most weak to the strongest. So the first one just says that the epsilon I, the error term, is mean independent from mi, fi, and qi. Okay, there's no correlation between the error term and the past indicator of metals, the future indicator of metals, and quality. Second assumption is not so strong either. It's just a normalization. We say that for wines that were not awarded in the past, neither in the future, we normalize the quality to 0 for these wines. The third is a bit stronger. It's violated in the data because you saw in the previous slides that there are wines that receive medals in the past and in the future. So this is something that is violated in the data, but for simplicity, we'll assume that a wine has either a medal in the past or a medal in the future, but not both. Next, the fourth assumption is our main identifying assumption. It says that the expected quality of wine I is equal regardless of whether a medal was obtained in the past or in the future. Okay? That's the crucial identifying assumption that you have to buy. Next, what we do is we estimate not the model, the previous equation, because we do not observe quality. We cannot estimate this model. But what we estimate is model 1. So we regress the logarithm of price on a constant and the both medal indicators, okay, MI and FI. So if you run this regression by OLS, beta 1 hat and beta 2 hat will be biased, okay, because MI and FI are potentially correlated with mu I, and mu I is by definition, it contains Qi. Okay, mu I is Qi plus epsilon I minus beta 2 times Fi. So there's potentially a correlation between our two regressors and the error term. So they're biased, both B1 hat and B2 hat, but under the conditions A1, A4, the difference, the expectation of the difference is equal to the causal effect beta 1. You see in equation 1, beta 1 is still beta 1. It's the same beta 1 as you saw in the structural equation. It's still the causal effect of the past matter. Now it turns out that this idea has popped up in another paper. It's Orly who told me that yesterday. It appears that Alan Kruger has this paper where the question of interest is what is the effect of college choice on current wage? And what does he have in his data? He has actually choice of college, so the actual choice, the actual college where the individual I went to, and all the colleges that I was admitted to. Okay? And so Alan had the same idea. His objective was to correct for unobserved quality bias of these students. By the way, we would like to have the reference of the paper, Orly. We would like to know if, in particular, the conditions, because beta 1 hat and beta 2 hat are not always, the difference is not always an unbiased estimator of the causal effect. We really need these four assumptions. So we are very curious to see what's in this education paper. So let us talk a bit about the results, and then I'll make 2 or 3 comments in 3 minutes, and then I'll stop. So here you see a table with beta 1 hat, beta 2 hat, the difference between beta 1 hat and beta 2 hat. The first column denoted all gives the results where we take n is equal to 1. Here in the column R, we group all the competitions and all the colors of the medals, and we define n as being equal to 1 if I has obtained a medal regardless of the competition and regardless of the color, and 0 otherwise, and F similar way, 0 if the wine will not get a medal regardless of the color and competition in the future, and 0 otherwise. So, and gold, the same thing. We take M is equal to 1 if the wine has obtained gold medal and 0 otherwise. S and B is silver and bronze. Paris and Bordeaux are the 2 main competitions, and other are these other competitions. So, the Feminalise, for instance. So, what do we see? We see that beta 1 hat, so the naive estimator, the bias estimator, that is biased by unobserved quality, is much larger than the difference between beta 1 hat and minus beta 2 hat. So the naive estimate of the medal is much larger than the true causal effect. We see that, however, that it is not significant in the first column. It's even negative for silver and bronze. And the biggest impact of the causal effect is for the gold medal and the 2 most important competitions, okay, Bordeaux and Paris. It turns out that it helps a lot when you add some explanatory variables. So we have added to equation 1 indicators for appellation. And here everything is, so I should have shown you only this table, by the way. Everything is just fine. All the differences between beta 1 and beta 2 hat are significant. Note that beta 1 hat and the differences, the causal effects are much larger. So apparently the results are very sensitive to the specification. So that is something we have to look at a bit more in detail. Can I make 2 or 3 concluding remarks, Olivier? Is that okay with you? Yeah? So we exploited this unusual feature in the data to identify causal effects of metals. We have looked, and we will look at some extensions, adding other explanatory variables. We do not have the proofs yet. When we say we, I should actually say Emmanuel, because Emmanuel has done all the computations, and Jean-Marie and me, we have just checked the proofs. The second extension is actually already done. So we allow for the fact that some wines have metals in the past and the future. We haven't really accounted for the fact, we haven't obtained the identifying assumptions yet for the case where wines can obtain multiple metals. So that's on the program as well. We were very excited about this idea of using future metals, but I think maybe the most interesting thing in this data is that the competitions are so different in nature, and we have these colors of these metals, and I think we should really exploit this aspect of the data and dig much more deeper in particular in the different effects of the different competitions. And finally, and then I'll stop, we have to try to come up with checking this identifying condition, which says that expected quality is the same for wines that were awarded in the past or in the future. Thanks a lot.